Hello everyone, welcome to my YouTube channel joho stream. Today I'm going to teach you an important topic in graph theory called single destination shortest path problem. I will explain this topic using very simple English and easy examples so everyone can understand. First, let us understand what is short path problem and what is the shortest path problem. The shortest path problem means we want to find the shortest or cheapest path from one place to another. We use a graph to show this. In a graph, nodes represent the places and edges represent the roads and weight represent the distances or the cost. For example, imagine a map with cities like Colombo, Kandy and Go. The road from Colombo to Kandy has 120 kilometers and the road from Colombo to Go has the 115 kilometers. If you want to go from Colombo to Kandy using the smaller distance, this is called the shortest path problem. Another example is Google Maps. When you search a route from your home to your university, in Google Maps shows the different path and it tells you which one is the shortest or fastest. Another example is delivery service. A delivery bike wants to go from the shop to the customer's house using the shortest route. So shortest path problem means find the best route for the minimum distance or minimum cost. Now let us understand what is single destination shortest path. Single destination means there is a one only destination. We want to find the shortest path from all other nodes to this one destination. For example, imagine a school. Students come from many homes like home A, home B, home C and home D. All students want to reach only one place, that means the school. We want to know what is the shortest path from home A to school and home B to school and home C to school. Another example is the hospital. People come from many villages to one hospital. We want to find the shortest route from each village to this hospital. And another example is the company server. Many computers send data to one main server. We want to find the shortest path from each computer to the server. That's called the single destination shortest path problem. Now let us see some more real world application for this problem. For example, in Google Maps, it is used to find the shortest route to hospital, airport or railway station. In GPS navigation, many cars want to reach the one place like stadium, hotel or shopping mall. In computer networks, data packets want to reach one server using the shortest path. In robotics, a robot wants to reach the charging station or exit door using the shortest path. In gaming, a gaming character wants to reach the treasure box or the target point using the shortest path. In delivery system, and the delivery rider wants to reach the customer's house using the shortest path. So this problem is very useful for in real life. Now let us talk about the algorithm used to solve this problem. The main algorithms are Dijkstra algorithm, Bellman algorithm and BFS, that means breadth first search. Each algorithm is used to different types of the graphs. First let us talk about Dijkstra algorithm. Dijkstra's algorithm is used when all edges weights are positive numbers. For example, road distances like 1 kilometer, 5 kilometers and 10 kilometers. There are no negative values. For the single destination problem, we can reverse all the edges, or we can start from the destination node and calculate the distances backward. For example, if the destination is the Colombo, we calculate the shortest distance from the Kandy to Colombo, from Go to Colombo and Jaffna to Colombo. Another example is if the destination is the hospital, we calculate the shortest distance from village A to hospital, village B to hospital and village C to hospital. Dijkstra algorithm would like this. It selects the nearest node, update the distances values and repeats the process and again and again. Dijkstra algorithm is very fast and easy to use, but it cannot work if there are any negative edge weights. Now let us talk about Bellman-Ford algorithm. Bellman-Ford algorithm is used when your graph has negative edge weights. For example, imagine a road where you get in fuel discount, so the cost becomes -3. Another example is a company gives reward for using a certain road. so the cost is negative. The Bellman fault works by checking all edges again and again and updating distances. It repeats this process many times and until the shortest distances are found. The Bellman fault can also detect something called a negative cycle. For example, imagine you go around the 3 roads and each road gives you the discount. If you go around again and again, your cost becomes smaller and smaller forever. This is called the negative cycle. Bellman fault works with negative weights, but it's slower than Dijkstra algorithm. Now let us talk about BFS, which means breadth first search. We use BFS when all edges have the same weight, usually weight 1. This type of graph called the unweighted graph. For example, imagine rooms connected by doors. Each door is one step. We want to reach destination using the minimum number of steps. Another example is social media. Finding the minimum number of friend connections to each person. Another example is mess. Each move is one step. We want to find the shortest path to the axis. BFS works by the visiting nodes level by level. The first time we reach the destination, that path is the shortest path. BFS is very simple and very fast, but it only works for unweighted graphs. Now let us see how to choose the correct algorithm. If the graph is unweighted, we can use the BFS. If all weights are positive, we can use the Dijkstra algorithm. If there are negative weights, we can use the Bellman fault algorithm. For example, in a mess game, use BFS. In a road mapping distances, use the Dijkstra. In a system with rewards or penalties, use the Bellman fault. So the algorithm chosen based on the types of the weight in the graph. Now let us understand and talk about the time complexity. The time complexity means how much time the algorithm takes when the graph becomes large. We use V for number of vertices and E for number of edges. For BFS, the time complexity is O of V plus E. This means BFS is very fast. For Dijkstra algorithm, the time complexity is O of E log V. This means it is fast and efficient. For Bellman fault algorithm, the time complexity is O of V times of E. This means it's slower than the other two algorithms. For example, if the graph has too many cities and many roads, BFS and Dijkstra will finish faster, but Bellman fault will take more than time. Now let us see a small example. Suppose we have a graph. A to B has cost 1 and B to C has cost 2 and A to C has cost 4 and C is the destination. As you can see, there are the possible paths. A to C with cost 4 and A to B to C with cost 1 plus 2, that means 3. Another example, village A to village B has 2 kilometers. Village B to hospital has 3 kilometers. Village A to hospital has 10 kilometers. The shortest path from village A to the hospital is village A to village B to and the hospital. They are with the 5 kilometer cost. If this graph is unweighted, we can use the BFS. If they have positive weights, we can use the Dijkstra algorithm. And if there has any negative weights, we can use the Bellman fault algorithm. Now let us summarize what we learned in today. We learned what is shortest path problem, and we learned what is single destination shortest path problem, and learned real world applications and about the Dijkstra algorithm, Bellman fault algorithm and the BFS, and learned how to choose the correct algorithm which of these, and we also learned about the time complexity. Okay guys, keep in mind the single destination shortest path problem means many starting nodes and one destination node. Thank you for watching this lesson on joho stream. I hope you understood in this topic clearly. If you like this video, please like, share and subscribe to joho stream.